Hey guys, welcome back to Detroit Garage. Today we're going to talk about Detroit injectors. A lot of you guys have been asking about those and how they work. So I'll do my best to explain them. I'll take one apart for you. I'm just doing up a set of 100cc injectors for the dyno mule here. Some of you guys are familiar with this engine and the new joiners. It's a 1988 Detroit Silver Series 453T, and we're trying to squeeze as much power out of it as we can with 90 and 100cc injectors. So at the moment we've got 9 G90s in it, and I haven't dynoed it with those yet, but we'll do that on the weekend. And then on the bench I've got a set of 9200s. They're 100cc injectors, and I think that might be the last injector in the test. My goal is to get this nearly smoke-free. The 9290s I tested just recently were almost smoke-free, really good. So with a bit of tweaking, I can get those cleaned up. Anyway, so a basic overview of how this system works. There's an engine-driven fuel pump on this side here. I'll show you that in a sec. So it draws fuel through this 25 micron filter. It goes to the line to the pump. And on the back of the governor is the fuel pump, and then it goes in the intake here, and then from there it's pushed out at about 60 to 70 psi back to the secondary filter, and then from the secondary it goes into a inlet here, if you can see my finger, and that is the inside of the head for the fuel delivery. And then when it goes through the injector, so once the fuel comes out of the injector and back into the fuel port, it comes out this fitting here, and it has a 0.080 inch restrictor on it. So by having that, it keeps the fuel pressure up to 60 to 70 psi. So out of the fitting here and back to the tank. So that's how that system works. Fuel flow through these injectors is a gallon a minute, so 60 gallons an hour, and that keeps the manifold, if you want to call it that, pressurized, and the injectors cooled. So the fuel comes in this inlet here, and it comes in here into the injector. Whatever fuel's not used comes back out to the return, and then again through here, and then out the hose. All right, there's the injector there, and that's the plunger, the follower here, and that's how the injector looks in the head. I'll go show you guys the injectors now. All right, so here's the body of the injector. Super simple. You've got your plunger here, well, your follower I should say, and the return spring, and that goes in here like that. Don't worry, I'll go through a more detailed explanation once I pull this other injector apart, but this is just a quick overview. So you have your spring that hooks to this, and it pushes this plunger in and out like that, up and down as the engine rotates. The camshaft in the engine pushes on the rocker, and then the rocker pushes on this, and it goes up and down. All right. So there's 2 passages in here. One is for the feed and one is for the return. So the fuel enters here, and it goes through just a very rough metal mesh. I don't know how many microns, but it's just a garbage collector, making sure no big chunks get in there. All right, and then it runs down through this port here, down into the injector. Already lost some parts here. And then this sits up against here. And you have a lower port and an upper port. And this is all cut. It's called the helix of the injector plunger. And it's shaped and designed to deliver the exact amount of fuel at a certain rate, depending on how much throttle demand you're asking. And the way it does that is it turns this plunger, and as it goes up, the bottom port here, it fills the barrel with fuel, and then when the plunger comes down, it cuts off that fuel, and then it injects that last little bit. So when the plunger goes down, both ports are closed, and then as it comes back up, fuel gets pressurized back into the chamber, and so on and so forth. And that's how that works. It's like a little piston pushing the fuel in and out. Okay, so the system's always pressurized at 60 to 70 psi. So as soon as that valve comes back out, boom, fuel goes back in. Then it pushes down. On this spring, and that in turn seals this whole unit off, and then pressurizes fuel into the injector through these small holes. As soon as the fuel gets pressurized, it lifts this little needle and sprays through the tip of the injector. These injectors are all different depending on, again, the model, the amount of fuel required, and so on and so forth. And that's the basic operation of these injectors. They atomize the fuel depending on the spring as well. There's a 3700 valve opening pressure spring, and then the normal one, which I think is about 22 to 2700 psi. And that's how these operate. So in order to rebuild these things, of course, you need a proper shop. This is not a proper shop. No. This is for giggles. I'm just experimenting. Like I said in previous videos, you send these out, they do a full rebuild on them. But I'm able to cobble together these things, and they work fairly well. And I've learned through these processes how the injectors work. Here's the list of all the different injectors. And this is what I go by for building and ordering parts for these injectors. I just get the part numbers on these, and I order the parts. So if I have a faulty tip, let's see, I go into, let's look at a 9200. So there's the 9200, and it requires a tip of 7-007. So 7 thousandths, 7 holes at 7 thousandths of an inch. And gives the valve opening pressure here. Well, if it's not 3750, like I mentioned earlier, it'll be like the 22 to 2500, something of that nature. I'm going to build up an injector to test popping pressures of these so I can know that. So the 9200, it lists 92 series, right? The 9 means 92 series. The 7, 71, and some of the 7s are 92 as well, and 53. So it's not necessarily number specific for the model. Generally speaking, the 9 series is for the 92, the 7 series for the 71, but as you can see, there are some 92, and let's see, is there a 53 in there? Yeah, 7505 is a 53. Okay, so there's literally thousands of different injector combinations. These plungers and barrels, here's a 35, an N35 out of a 253. It's 35 cc's. So here's the bigger 90 series injector plungers and barrels. There's the old 35s. As you can see, this here is a much larger injector to get more fuel into the compression chamber, I suppose you call it, delivery chamber. So again, these get bigger with the bigger injectors. So for timing these injectors, the rocker pushes down on this follower. So when it's in the engine, you want to time it, you get your tool out and you can time it here like this. This is the timing tool right here. And you've seen me in other videos timing the injectors. This sets the height of the injector. The higher the height, the more delayed the injector is at delivering the fuel. The closer down it is, the more advanced it is for delivering fuel. All right? So if you look at a 1.5 inch tool, I don't know if that's going to pick it up, but the 1.5 is longer here than the 1.484. All right, so that's how you time them, just with this little tool. So here's that tool I talked about. It fits in a hole in the injector body, and it's just a depth gauge. That's all it is. And you run it along here, just rub it on the follower, make sure it's just touching, and that's all that is. And then I know this injector is timed correctly. To control the fuel, you have this little unit here, the rack, and all the way in is full fuel, and all the way out is fuel shut off. A little bit like that is idle. That's half throttle, 3/4, full. And what controls this whole thing here is the governor. So I'll show you that now. So here's the governor. It's just a gear-driven governor off the accessory gears. That's super simple. You got your on-off here, and then you got your throttle control. You won't see much throttle control because the engine's not running. So right now, the engine's at idle. All right, as soon as I do this, it's going to pull the throttle back to fuel shutoff. You look at these little fingers, they're going back to idle shutoff or fuel shutoff. All right, and that's how that works. Just that simple little control. So full fuel demands, you see this moving? Demands the rack go full fuel, and what controls it from a runaway is this governor. The weights fly out, apply force, and bring the fuel back automatically inside the governor to control the rack. All right, and that's how the speed of the engine's governed out at whatever you set it at. This one now is set at 2800 RPM. So with no load on, when I go full fuel, the engine revs up to 2800. What I'll do, I have to steal the internals out of this unit and put them into, I can keep track of this stuff. I'm going to build this injector now. All right, I had to steal parts from this one to make these, the 9E85s to test. Okay, so bear with me, I'll get this set up and we'll take this injector apart. On Cummins, Mercedes, well, you name it, almost every manufacturer either has, in the day when Detroit had these mechanical injectors, mechanical unit injectors, other competitors had, like Rusa Master on their lineup of engines, like Buda, Perkins. This rotary pump was used by Bosch as well, and it came in the Cummins and all kinds of different engines. They also had a P pump that was like a piston pump. Bosch made those, and they made them for Mercedes-Benz. So this is an injector out of a OM 621 Mercedes, and you would have had your P pump with injector lines delivering fuel in here, and then the return came out of here through a little manifold. So the pressure was developed from that pump. So you had all these items, whereas the Detroit just has this unit, does everything. So Detroit ran these from the beginning of inception in 1938 right up until the end on some engines, until they stopped making them. And in the mid 80s they upgraded this mechanical injector to a EUI, electronic unit injector, and they basically got rid of this rack system and they put electronic controls in here, and they called it a DDEC, which is a Detroit Diesel Electronic Control. It was the early version of the common rail, if you want to call it that. Very simple, same delivery system. You had that engine-driven pump delivering 70 psi. You still had these units here taking in the fuel, but what controlled the throttle, governed the throttle, was an electronic device inside. Unfortunately, I don't have one to show you guys, but that's how that worked. Later on, the four-strokes came out in the 90s, early 90s, and they incorporated the DDEC into the Detroit 60 and the 50. Those turned out to be really good engines, and then they phased out the two-strokes due to emissions, basically. They just couldn't clean them up. So the 60 series had that DDEC, and then they came out with the later models with the common rail. I believe Mercedes-Benz owned them at that time and revamped the whole thing. Came out with a whole new engine, and that's what's on the highway today, the DD15 and 16 and other variants. They're common rail now. So back to Detroit 60s. After they use their useful life, again, EPA emissions demanded cleaner emissions. So they went to the high pressure common rail system, just like everyone else did. Every manufacturer now that's still in business making new engines has a common rail system. That's just the way it is. Yeah, to keep up with emissions, everyone had to go that route. So this injector here was also used by other companies, not just Detroit Diesel. Caterpillar did this for the 3116 engine, and possibly others. I'm not aware of them, but I know for a fact there was a series 3126 possibly, and the 3116 had these injectors. And again, you had to run the rack and do all that stuff. So I'll take this injector apart quickly, as I've got to build up an injector. I'll show you the bits, and then I'll go over to the engine and I'll just show you the timing of that injector. All right. So the injector does everything that these other injectors or other pumps and systems do, just with the injector alone, nothing else. So that's what's really nice about it. It's all in one. So it times the fuel, it atomizes the fuel, it meters it and injects it, and yeah, simple. A lot of you guys have asked me, why don't I put electronic injectors in this thing? Why don't I put common rail in it? Why? My answer is because I really enjoy the old, simple mechanical injection system. It's simple, it's cheap, it burns veg oil, which I drive daily with. If I go to a common rail system on this engine, I'm opening up for a lot of hurt. The cost of running electronic injectors, be it Detroit DDEC or the common rail CP3 pumps or CP4, you name it, they're all expensive. I don't know if they burn veg oil. I guess I could get a system, but it's thousands and thousands of dollars to retrofit my engine to a DDEC. And even more if I decide to go with the common rail. Jason over at Fat Cabs, if you've seen his truck, he's running 8V92T, drag races it. And wow, that is one awesome system. As we speak, he's rebuilding it, he's adding bigger, better, you know, he's always improving the system. And that's what's, you know, that's what you need to do if you want to try that stuff. Wow, you need to set yourself up with a dyno like this and just be on it all day long, improving stuff. So I'm just keeping mine simple. I'm going to try to squeeze out 275 to 300 horse and leave it at that. I'm happy with that. I'm very happy with the 9290s. They were awesome. So we'll see how the 9G90s go. I'm pretty optimistic about those. So let me pull this thing apart. I've just got to tidy this up so I don't mix all the parts up. So we're going to take apart this 9E85. It's an 85cc injector. And we're going to build a 9200 out of it. Alright. The only difference was the tip. Smaller tip, but it uses the same plunger and barrel as the 100cc injector. And that's another thing I like about these injectors is I can repair them. With these modern injectors, I can't. These injectors are very simple and very forgiving. So there's the interior of it. And I'm just going to screw that right back on this injector I stole it from. See? I've already run the engine with this injector in it. A modern system would not tolerate that at all. See, that's a little bit of scaling from sitting. Anyway, we're going to put that back in there. I've stolen the caps out of it. So I know it's basically unserviceable, so I have to go through it and make sure it's okay if I ever want to use it. So here's the plunger and barrel out of a 9200. So I'm just gonna steal the parts. Really all I'd have to do is switch tips, but for this exercise I'll show you guys how these are put together. Alright, so we're going to pull that out. That's the barrel, we're going to set it there. And then here's how that turns when you add and subtract fuel. See, that's idle and that's full fuel. Okay, we're going to pull the keeper pin out. Clean up some of this stuff here. Simple as that. Just pull that pin out and the whole thing comes apart. We'll set it right down on that. All I'm going to do is transfer that into here. Okay. So I'll put that over here. And I'll pull this little piece out. So you see the little gear set? That's what controls the movement of the plunger. So that simply just drops out like that, and now comes your rack, and then you're down to the bare body again. And that goes in there. I'm just going to blow this out with clean air. So on the rack, It's got the gears. See that? They line up with this. So we're just gonna drop this back in. Now I've done a video on this before, but being you guys keep asking me about it, I'm just gonna make another one. So you gingerly drop that in. Make sure it's timed. All right, with any luck the camera picks that up. So you know that's timed correctly. If you get that wrong, the engine's never gonna run right. Then that collar falls back in there again. Then we put the barrel back in. And then I confirm before I fit this back together that this is an F10. It says F10 on it. Then I know it's the correct plunger and not an F9. An F9 is the 90cc injector. I'm going to screw the body back down on here. So I'll need an O-ring. Make sure I've got the right tip. It's a 7-7. Oh, there's one more thing I want to show you guys. Just give me a minute. So here's the tube, the injector tube that's in the head. The injector seals into this. Can you see inside that? It's tapered exactly to fit this. And that falls in there like that and seals at the bottom. I'm not going to push it all the way in or I won't be able to get it out. But these two pieces are mated to each other. And this goes into the head, seals at the top and seals at the bottom. And then is cooled with engine coolant. There's no seal like on a Bosch, like a Mercedes-Benz or a Cummins or any other manufacturer for that matter. This one here had a little disc that went in and that's what sealed it in the pre-cup. So it's direct injection, not a pre-combustion system. So this one here is happens to be a Detroit tip, which I like to see. So this is how that goes together, and then we put the coffee can over it. Like that. The spill deflector, I think they call it. And then we stuff it in there like that. Then I don't lose anything. Then I'm going to screw this back together. All right. Then what I got to do now, put the plunger in. Do that. Okay, so now we put this back in. And slowly rotate this back and forth until we find that flat spot. There. Now I have to line up this hole here. So that I could put the pin in. So I could see that. It's pretty hard to see that on camera, but the pin is ready to go in. See if I could do this without putting it in the vise. There. And then make sure it's locked. And that's an assembled injector, believe it or not. So what we're going to do now is we're going to bench test it and make sure it sprays. So let me tighten this up first, and then we'll bench test it. All right, after you've torqued it, everything should be really nice and free. If it's not, something went wrong. See? See the rack move like that? That's how it should be, all right? So now we're gonna prime it, and I say bonk test it. Bonk, bonk. Got my trusty test tube. We're gonna use just WD-40. So Jimmy doesn't care if it's WD-40, if it's diesel. We tested this tip. It's no good. So, see that? That's no good. We're gonna have to find a better tip. Not to worry. I'll show you what a good injector should spray like. There, that's better. So that's the injector complete. I've got to take this tip out and find a good tip. And let's hope I can find one, otherwise I have to order one. But I have confidence that I'll find one. Well, there you have it, guys. That's an overview of the ejection system on a Detroit two-stroke. They're all the same. They all use that system. So once you know this one, you know them all, basically. Super simple and really nice, really nice. Once you get used to them, they're really, really nice. So thanks for checking in, and we'll catch you on the next video. Take care.